Alright, so yesterday we went over 1.24 comparing distributions of data. Well, comparing distribution of data, provide a meaningful graphical comparison of the data, such as parallel box plots, or histograms made on the same scale. When comparing the data, you need to compare the shape of the distribution, including any significant gaps or clusters. Compare the center of the data and context as using appropriate units. Do not simply list the statistics. Compare the spread of the data and discuss any outliers if appropriate. Today, we will be working on lesson 1.3.1, Where Do I Stand? Your I can statement for today is I can use percentiles to compare relative standing within distributions of data and use data in histograms to make ogives. Your core problems for today is core problems 1.57 through 1.59. These problems are dealing with using your regular data table and answer questions based off of that, creating relative frequency tables, and then creating cumulative frequency tables, and then using those cumulative frequency tables to make ogives and answer questions based off of your data table that you came up with. Your closures for today is to order the steps needed to go from original data to a cumulative relative frequency, and what should the total relative frequency equal? What should the cumulative relative frequency equal? So before I gave you watch the next video, your data is often not meaningful unless it is compared to other data. What is interesting about your batting average or free throw average if you're the only person that has it? What is interesting about your ACT score if you're the only person that has that ACT score and you have no one to compare it to? So this lessons for today is having you work through how do we compare ACT scores, and how would we come up with the data to compare your scores to other people's scores. Hey guys, so I'm using the math notes today to go over your lesson for today because I want you guys to start referring back to your math notes whenever you're getting stuck. Whenever you get stuck on the lesson, the questions, because the questions are giving you the step by step of why you're doing something. Is really CPM is really inquiry based because they want you to figure out the background behind making a histogram and calculating standard deviation. Why you use standard deviation? Why you're using variance? Is wanting you to know the why before you do the do. So for today, we're going over relative frequency histograms and ogives. This is pronounced ogive, even though it's spelled like ogives. It's pronounced ogives. So you're going to examine the tables below in the histogram. So the histogram is reflected to the table to the next to it, to the left of it. So this is just a basic table and a basic histogram, nothing to it. You have done this multiple times. Now, here go the new stuff. You're now using the frequency table, the table to make your given data to make a relative frequency histogram. Your relative frequency histogram reflects the percentage of what occurs. So I would do F 0 divided by 40 is 0 to get that relative frequency. 3 divided by 40 to get 0.075. So you just basically dividing your frequencies, your frequencies by the total to get the relative frequency. All of your relative frequencies should add up to 1 because these are basically percentages. So the difference between the regular histogram and a relative frequency histogram is the y-axis. Your x-axis stay the same. Your temperature stay the same. Your y-axis changes because it's going. It is now based off of the new y. Your frequency is going to be based off. Your y is going to be based off your frequency. So your lowest point is 0 and your highest point is 0.4. Even though this is wrong on my paper, it should be 0.4. So your histogram still look the same because it's basically the same percentiles, the same percentages. It's just the same data but in percents or decimals. Now comes to the cumulative frequency, relative frequency. You use cumulative relative frequency to calculate the percentiles. Like you hear questions like, what percentile? After you take a ACT test, we look at what percentile you fall in based off of your score. So we use the percentiles to figure that out. To calculate the cumulative relative frequency, you use the relative frequency. There's a lot of these words are tongue twisters. You use the relative frequency to calculate the QR. I'm calling it QR. So for the first data point, right? For 55 to 55 to 60, I'm going to add. Hold on one second. The relative frequency to what's above. So my relative frequency is 0 for 55 to 60. Nothing's above it, so I can't add anything to that frequency. So it's 0 plus nothing. So 0 plus nothing is 0. So that's why your relative frequency, your QR, stays the same. And then for your second one, so your second interval, 60 to 65, you're adding that frequency to what's above it. So 0.75 or 0.075 plus 0, you get 0.075. For the next interval, 65 to 70, I'm adding the current frequency to everything that's above. So 0.275 plus 0.075 plus 0, you get 35.35. Then for the next one, I'm adding the current frequency to everything above, you get 75. And then for the next one, for the next interval, I'm adding everything above plus the current one, and you get 0.75. And then the last one should always be 1. Your last data point, your last interval should be always be 1 because all of this is equal to 100 or 1 or to 1. In percentages, it will equal to 100. Now comes the ogive. Your ogive is basically making a line graph using the same interval, so your same y-axis, your x-axis, and you're just using turning your y-axis to percent, so your percentiles. So your percentile should always be, your y-axis should be always be labeled 0 to 100 real quick. So you use that percentage to use these decimals to calculate your ogive. So based off of your 55 to 60, it'll be 0. And then 60 to 65 would be 0.075. So it goes up by percentages. You can use the ogive to answer questions like, what percentile does the room that has 65, the temperature of 65 Fahrenheit. You will look at the temperature and you say, go up and see what percentile does the 65 land in. So it lands in basically 1%. Then you can use the ogive to calculate the 5-number series summary. The 5-number summary is the mean, quartile 1, median, quartile 3, and your max. So for this graph, your median, your min will be this point. Your max will be this point. Your median is half of your data, so half of the y, so it'll be 50. So I'm trying to approximate a line. It'll be 50, and then it will tell you will draw a line down. This is your median. Your quartile 1 is 1/4 of your data, which is 20%, or to the 20 percentile. And then your this is your quartile 1. Your quartile 3 is 3/4 of your data, which is 80%, or 70%. I think it's 70%. It's 70%. And you go down. See quartile 3. So your mean will be 60. Your minimum will be 60. Your quartile 3 will be like 60. I'm gonna say 68. 68. That's supposed to be 8. 68. Your median is wherever it falls on the x-axis. I will say 70. No, I don't like counting these. I'm gonna say, yeah, 70. You just get the gist. And then your quartile 3. Quartile 3 will be a little bit after that, so 78, and then your max will be 85. So that's how you find your 5-number summary. So you use the 20, the 50, and the 70, and then your min and your max. Min, max. I don't think you can see that.